Okay, so today we're going to do solving trigonometric equations. This is following all our simplifying and verifying. Y'all just took the test on that, so that should be something you're comfortable with. Now we're going to go back to your favorite thing, the unit circle. So, so solving trig equations is very similar to what we did back, I want to say right at the end of the semester when we did that unit circle rewind and those kind of questions when we reviewed for a midterm. But anyway, so when you're solving an equation, you're basically finding the points on the unit circle that make the equation true. So if I'm looking at this first example, sine of x equals 1/2, my whole job is to figure out what x makes that equation true. So we need to remember from our unit circle that sine is your y coordinate. So your job is to go looking around your unit circle to figure out everywhere your y coordinate is 1/2. So when I look at that, I'm going to go around and my y coordinate is 1/2 here at pi over 6. And my y coordinate is 1/2 here at 5 pi over 6. So my two answers are pi over 6 and 5 pi over 6. So this is something you have done before, we just didn't call it solving trig equations back then. Now, it's obviously not ever going to be just this easy. So we're going to throw it into equations like this, where you have 2 cosine of x plus 1 equals 0. Now notice these constraints, okay? This is really for your x, not your theta, but it's saying that all your answers need to be between 0 and 2 pi. So the reality is it's just any angle that lies on your unit circle that we can see. So when I go to solve this equation, you're going to solve it just like any other equation for x. So I'm going to subtract 1 first. So I would have 2 cosine of x equals -1. And then from there, all I'm going to do to get cosine of x by itself is divide by 2. So I'm going to have cosine of x equals -1/2. So now I'm kind of back to something like we did on the page before. Once I get cosine of x by itself, my job is to now go to the unit circle. And remember that cosine is my x coordinate, so I'm going to go looking for everywhere my x coordinate is -1/2. So if I do that, okay, and I go looking for where my x coordinate is -1/2, all right, I will find that my x coordinate is -1/2 at, right here, at 2 pi over 3, and also at 4 pi over 3. So then my answers for this problem are 2 pi over 3 and 4 pi over 3. Okay, so when you're solving an equation, you're just going to get the sine, cosine, or tangent by itself, and then go looking at your unit circle. So as we get more involved, now we're going to get into something that has squares. Same deal. My whole goal is to get cosine of x by itself. So just like any other equation you would solve, you're going to add 1. So 4 cosine squared equals 1. Then we're going to divide by 4, just like you would always do. So cosine squared equals 1/4. Now here's the difference. If it's cosine squared, we have to remember to undo a square. We always need to take the square root of both sides. Now, what do you always have to remember when you take the square root of both sides? Haha, plus or minus, don't forget or you're not going to have enough answers. So then from there, then you're going to always, when you're square rooting a fraction, remember you're going to square root the top and square root the bottom. So what we're going to end up with is cosine of x equals plus or minus 1/2. Okay? So then my job is to go to my unit circle and figure out everywhere the cosine is plus or minus 1/2. And remember, cosine is your x coordinate. So when I go back to my unit circle, where is my x coordinate plus or minus 1/2? So that's interesting. That means that could be here at pi over 3. That means it could be here at 2 pi over 3 because it can be positive or negative. It could be at 4 pi over 3, and it could also be at 5 pi over 3. So really our answer is everything over 3. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And guys, that's because it was a plus or minus. Anywhere your x coordinate was plus or minus 1/2, I had to provide an answer. So then, please don't let the square root of 3 mess you up, guys. This is nothing more than a plain number, okay? So this is the same idea. You're going to get cosecant of x by itself. So you're going to add 2, just like always. So square root of 3, cosecant x equals 2. And then, again, just divide by square root of 3. Now this is where, please don't jump the gun and start rationalizing, okay? I know we're not allowed to leave radicals in the bottom, but I also know that when we look at our unit circle, we don't know anything about cosecants. So from our last unit, cosecant is the reciprocal of what? and you should be saying sine. So if I want to flip this thing over, I can. And I can flip this over to say that sine is the square root of 3 over 2, or the reciprocal of cosecant. So once I get sine by itself, I'm ready to go to my unit circle, okay? And when I do that, sine is your y coordinate, so we're going to go looking for everywhere the y is square root of 3 over 2. So everywhere our y is positive square root of 3 over 2. And guys, that's going to be right here and right here. So pi over 3 and 2 pi over 3. So that's the basics of solving. We're only doing day one, so it is pretty basic until we branch off into one like this that I would normally have you try on your own. I would like for you to probably try it on your own. Maybe this is somewhere you could pause this video and try this example and see if you get what I get. If you choose not to and you just want to listen through my work, that's fine too. But the same idea is here. You're going to want to add 4. So 3 secant squared x equals 4. And then just like anything else, divide by 3. So secant squared x equals 4/3. And then again, to undo a square, we square root. And then we get secant of x, don't forget your plus or minus, is the square root of 4 over the square root of 3. Which, y'all, is secant of x equals plus or minus 2 over square root of 3. Now, this is very similar to the one I just talked about. We don't know secants on our unit circle, so we're going to go ahead and we know that secant is the reciprocal of cosine. And so we're going to take the reciprocal of this, so plus or minus square root of 3 over 2. So now once I have cosine by itself, my whole job is to go to the unit circle, figure out everywhere the cosine or the x-coordinate is positive or negative square root of 3 over 2. And guys, you're going to find that's everything with a denominator of 6. Okay? And I'll show you over here. So where x is square root of 3 over 2. So that's right here, square root of 3 over 2. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So, 4 answers most of the time is as many as you're going to have when you're doing these types of problems. Now, we're going to get fancy. This looks completely different than everything we've done before. And you may be looking at it and be like, I don't know why it looks any different, but the biggest thing is this thing right here, okay? And that is something that makes this completely different than all the others. Typically, we've always had an x rather than a 2x. What you cannot do is go through and divide everything by 2. So, like, you can't do that. Don't ever, ever, ever do that, okay? The big idea here is you can't touch that 2x until after you go to your unit circle. So what I mean is we're going to go ahead and get sine by itself like we always would. So we're going to divide by 2. Okay, when we do that, it just cancels that 2. It does not mess with the 2x in the box. So I'm going to be left with sine squared of 2x equals 1/2. And then just like before, we get rid of the square by taking the square root. Take our square root, so we're going to have sine of 2x. Don't forget your plus or minus. And then the square root of the top and the square root of the bottom. So I'm going to have sine of 2x equals plus or minus 1 over the square root of 2. Now, typically, we go ahead and flip it over and move on, but this is already sine, which means we're going to be looking at our unit circle, so we need to rationalize this because you're not going to find this on the unit circle. So it's plus or minus square root of 2 over 2. So our whole job is to go looking at our unit circle. Now, if you'll notice from every problem I did before, when I was solving and I went to my unit circle, I always wrote x equals. Now I'm going to write that 2x equals. And my job is to go to the unit circle and figure out everywhere the sign is positive or negative square root of 2 over 2. And y'all, sine is y, so that's going to be everything over 4. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now, most of the time we get accustomed to just, that's our answer, and we're done. But now it's 2x equals all of this rather than just x. So we have to go through and get x by itself. And we're going to do that by dividing by 2. Now, I feel like dividing by 2 is a little bit hard with fractions, so y'all need to remember that dividing by 2 is the same as multiplying by 1/2. It's going to make your life easier. So you're going to go through and multiply everything by 1/2. So you're going to get pi over 8, 3 pi over 8, 5 pi over 8, and 7 pi over 8. And guys, those are going to be your answers, okay? So don't touch the 2x in the box until the very end after you've gotten angles off your unit circle. So we're going to do one last question, okay? And I want you to make sure that you're kind of paying attention to what makes this different than all the others. And what you should notice is we have this x over 2, y'all. That's what makes this different. The cool part is there's nothing else I have to do to get tangent by itself. It's already by itself. So my job now really is to just figure out everywhere on the unit circle where the tangent is square root of 3. So I have x over 2 equals. Now, this is where it's helpful if you memorized your tangents from back in the day, okay? So if you memorized your tangents, which is something I hope you did, okay, you should memorize that your tangent here is square root of 3 over 3, this is 1, and this is square root of 3. This is negative square root of 3, negative 1, negative root 3 over 3, square root of 3 over 3. Okay, so when we're looking at our tangents, I'm looking for everywhere my tangent is square root of 3. So everywhere tangent is square root of 3, that would be here, and then that would also be here. So my answers would be pi over 3 and 4 pi over 3. Now, pi over 3 and 4 pi over 3. But guys, if this was like a multiple choice section on the test, those are going to be distractors, okay? You need to remember that you still have the lovely x over 2. So I need to get x by itself. So to undo division, remember that's multiplying by 2 over 1. So we're going to multiply each of these by 2 over 1. So I'm going to end up with 2 pi over 3 and 8 pi over 3. All right? Now, we have a problem, okay? And this is the only time it's ever going to happen is if you have x over 2, x over 3, x over 4. But remember, our x is supposed to be between 0 and 2 pi, okay? 2 pi over 3 is clearly between 0 and 2 pi. It's 2/3 pi's. But what happens with 8 pi over 3? If you look at this one, this is the same as 2 and 2/3 pi's. Is that within the window between 0 and 2 pi? You should be telling yourself, no, it's not. It's bigger than 2 pi. If that's the case, then it's not a solution within the window that we are solving our equation for. So our only answer would be 2 pi over 3. So if you get an answer that's outside of that window, you're just going to eliminate it and only use the ones that fit within that range. Okay? So that's it. That is solving trig equations, and we still have 2 more days of solving more difficult problems with substituting and factoring and things like that. But these are just the basics just to get us started.